So good morning students, welcome back. Today we'll start lesson number 5, magnetism and magnetic property. So let's start with the definition of magnet. Okay, magnet and magnetism. What is magnetism? A magnet is a piece of material that has both attractive and directive properties. Both attractive and directive properties. It means these materials attract the object and it will also show the direction. Later on we'll discuss about the direction. It attracts small piece of iron, Fe, nickel, Ni and cobalt. These are magnetic element. This attraction property is called magnetism. So some natural substance are there, okay, that attract, okay, the other object towards it and also show the direction are said to be simple magnet. Okay, actually there are two types of magnet, a natural magnet and artificial magnet. Before coming on that, I want to tell you the word magnet, the word magnetism is taken on behalf of the name of island in Greece, okay, where some natural magnet were found early in the 6th century, okay, and that island is said to be Magnesia. The name of island is Magnesia. On behalf of the name of island Magnesia, it is taken the word magnetism, okay, where the natural magnets were found early in the 6th century. Okay, so what is magnet? These are natural substance, okay, that having the attractive property and that also show the direction, okay, that is said to be magnet. And on behalf of, it is of two types, okay, we can make also, it is found naturally and we can make also. So on behalf of that, it is of two types, natural magnet and artificial. So let's start first with natural magnets. So what is natural magnets? Those substance, when we suspend it in air freely, it aligns itself towards geographic north and south of the earth. It means in whatever, in which direction, in any direction when we suspend it, automatically it aligns itself towards north and south of, geographic north and south of the earth, are said to be a natural magnet. Our earth is a example of natural magnet. Hematite, magnetite, these elements are said to be natural magnet. Okay, now students, let's start with artificial magnet. What is artificial magnet? Whenever, suppose we are having a cylindrical shell, when we wound copper wire on it and when we pass electricity, it behaves like a magnet. That is said to be artificial magnet. Okay, the example is solenoid, toroid. That would be the first is natural magnet. As I told it, when we suspended the element freely in air, automatically it aligns itself, okay, towards the geographical north and south of earth. Okay, natural magnets is an iron are called magnetite, Fe3O4. Okay, these substances said to be the part of natural magnet. It always comes into rest in north-south direction when suspended freely in air. Okay, our earth is the best example of natural magnet. Beside that, Fe2O3 hematite, Fe3O4 magnetite. These are also said to be natural magnet. Okay students, now we'll come on that artificial magnet. Artificial magnet, piece of iron and other magnetic material can be made to acquire the properties of natural magnet. Such magnets are said to be artificial magnet. Example, solenoid, toroid, electric bell, electric crane. Okay, and if you remember, solenoid and toroid we did in the previous chapter in the application of Ampere circuit law. Suppose we are having a cylindrical shell. This is a winding, copper winding. When we wound copper wire, when we pass electricity, it produces magnetic field around it and the system behaves like a magnet. That is said to be solenoid and that is the example of an artificial magnet, and it behaves like a magnet till the current electricity passed through it. When the supply of current stopped, when we stop the supply of current, it behaves like a normal material. Such elements are said to be artificial magnet. We can provide the property of, we can feed the property of natural magnet in some element, magnetic element, and it become artificial magnet. Okay students, now students, we'll discuss some basic property of magnet. Okay, the first property is attractive properties, that you know very well. A magnet attract small piece of iron nickel and cobalt. Okay, look at. So this is a magnet, it attracts another element. Okay, it attracts the small iron needle. Look at students. So this is said to be attractive property. Okay, now students, the second is directional property. As I told that when we suspended the magnet freely in air, it aligns itself in geographic north and south of the earth, and we can detect the direction. We can identify the direction. In olden days, before GPS and all new systems, the only the method was to find the direction is that magnet. Okay, a freely suspended magnet align itself nearly in geographic north-south direction. In this way you can find the direction using second property. Now third is magnetic poles. Okay, every magnet having 2 points at which the attraction power is maximum, the intensity of attraction is maximum, such point is said to be poles. And every magnet having 2 poles, north pole and south pole. These are the reason of apparently concentrated magnetic strength in magnet, where the magnetic attraction is maximum, are said to be poles. Every magnet having 2 poles, look at students, okay, that is north and that is what? South pole. Okay, students, the fourth property is magnetic poles exist in pair. Isolated magnetic poles do not exist, monopole does not exist. If we break a magnet into 2 small pieces, we get 2 smaller dipole magnet. What is the meaning of that term? This is a magnet having 2 poles, north and south. Its effective length is L. The distance from north to south pole is called effective length. When we break magnet into 2 parts, okay, the remaining part will also get again 2 poles, north and south. It means we cannot separate both the poles. Monopole does not exist till now. Okay, so when we break the magnet into 2 parts, again the remaining part will also get the same north and south pole. It means we cannot separate the poles north and south. Now students, fifth is pole strength, that is represented by small m. Every magnet having 2 poles, north and south, and at north and south pole, attraction power is maximum. So the maximum attraction power, the maximum intensity at north and south is said to be pole strength. It is represented by small m. Both the poles having equal and opposite pole strength. Okay, suppose if north having minus m, south also having plus m. If this is plus m, that will be minus m. The maximum attraction power at poles is called pole strength. Both the poles have equal and opposite pole strength. Okay. Now students, effective length, that we did. The distance between north and south pole is called effective length, represented by small l. And the last definition is about magnetic dipole moment, one of the most important definitions. So let's get started. Okay, what is magnetic dipole moment? Look at students. Our next is magnetic dipole moment. So look at students. Suppose we are having a magnet, obvious 2 pole, north and south, having pole strength minus m and plus m, and its effective length is L. So magnetic dipole moment is defined as the product of pole strength and effective length. Magnetic dipole moment defined as the product of magnitude of pole strength and effective length, small m into L. It is said to be dipole moment. Okay. One more formula we can write about dipole moment, that is NIA. That we did in previous chapter. In which chapter? We did in that torque on a rectangular coil. Okay. N is number of turns, I is current, A is area of coil. Okay. We know what is the unit of current? Ampere. And what is the unit of area? Meter square. So what will be the unit of magnetic dipole moment? Ampere into meter square. That will be the unit of magnetic dipole moment, having 2 formula. This is on behalf of pole strength and effective length, and this is behalf of current, area and number of turns. So pole strength is basically magnetic dipole moment is basically defined as the product of pole strength and effective length. Other formula is NIA, where N is number of turns, I current, A area. number of turns having no units, current having unit ampere, and area meter square. So ampere into meter square will be unit of magnetic dipole moment. Understood, students? So this is the basic about magnetism. In next lecture we'll start the main topics, okay, of the chapter magnetism. Okay, students.